So what is a function? Here it goes. Yes, Matthew?
A relation that pairs each input with exactly one output is a function.
Oh, okay. What is a function? We wrote this already, right? Yesterday? Yeah? What is a function? What is the definition of a function? And the book says this. We wrote it yesterday, but the book says a relation. You don't have to copy. You copied it yesterday, right? A relation that pairs what? What does it say? Each input with exactly one. That's the key thing right there. With exactly one what output? Is a function. Okay. Now let's break this down. Ready? Does anybody know what that's saying? Can anybody tell me what that's saying? Yeah, go ahead.
They shouldn't cross and they should only match one.
Okay, you said they. Right there when you said they, I don't know what you're saying.
Like the numbers, like in the pairs, they should just go to one output.
Okay. So let's remember. So the input is remember the input is the what? The x coordinates, right? We'll just put x. Each input, each x coordinate, each input with exactly one. Oh, output is the y, no? Okay. So say that again. What were you saying?
But like, if I say that each input should be paired with one output, so only one should match the one.
So you're saying only one what?
Only one x should match the one y.
Okay, he said only one x should match with one y. So, okay, all right. I'm gonna make this simple. I'm just gonna tell you, because it's gonna be easy to get confused what's going on here. All right. So get that graph paper. I gave you guys graph paper, right? And remember, if you need graph paper, if you're at home, I put it on the yellow folder on Schoology where you can print it out. Okay, so we're going to look at this visually first on graphs. Okay. Go ahead and plot this. Ready? Go ahead and put 7, -7, 2. Let me zoom in a little bit here. How about -4, 2? How about -1, 2? How about 3, 2? Whatever. One more, 6, 2. But right now we're not looking at them as coordinates, right? I can write this as coordinates. I can write this as a table. I can write this as a mapping, right? You know what? Let's write that. Let's write it as coordinates. Everybody agree this is -7, 2, -4, 2, -1, 2. What was the other one? Oh, 3, 2. And 6, 2. Yeah. Okay. And if I write this as a mapping, I mean, I can write it as a table, but it would be the same thing. But if I write it as a mapping, what would it be, you guys? Wouldn't I need to put the one thing right here, the x is here, the input, and then the output over here? If I do a mapping, it would be, what, -7, -4, -1, 3, 6? And then what would be the, oh, what? This is the input, or this is the input. This is the x's. And this is the output, the y's. And what do I put over here? A 2. Oh, what the hell? Just a 2 like that? I'm not going to write a bunch of 2s. You just need to write it once. And if it was a mapping, wouldn't it look like this? Wouldn't they all just be going like this? Yeah. Okay, now, the question is this a function? Is this a function? That's the question. This is what we're going to figure. Is this relation, right? If I say this, what's this? Is this relation, right? I'm showing you the same relation three different ways, right? I'm showing you the same relation three different ways. And no matter whether I look at it like this, or whether I look at it like this, or whether I look at it like this, is this relation a function? Yes? Who says no? Who says yes? Let's look back at the definition of a function. Right, that's this investigative thing we're looking at now, because I want to make sure that you're solid with this. It says that a relation that pairs each input with exactly one output is a function. So it what? So it is. Samantha says so it is. Who thinks it isn't? Who thinks it isn't? And the rest of you are like, I don't know, what the, right? Okay, Samantha, you say it is. You're correct, Samantha. Why? Why do you say it is? Like, how are you looking at this?
Because it says that each relation, like if there's, sorry, that the relation that says that each input has to only go to one output.
Ah, say that again.
So that each relation of an input has to go to only one output.
You see what she said? She did not say the book. She did not say it the way the book wrote it down, but she used her own words. And just a couple of words that she changed clarified it. It made more sense to me. And she's right what she's saying. Say it one more time, Samantha. It only goes to one output. Each input, each x value can only go to one. Can only go to one. Is it okay if it goes to two of them? No. It would not be a function. So if x is -7, it can only go to one y. What if I had a point here and another point over here at -7? That's when it fails. That's when it's not a function. If I have x at -7, it could only go to one number. Is -7 only going to one number? Yes. Is -4 only going to one number? Yes. Is -1? It doesn't matter if it's the same number. See, you guys are confused because it's like, well, why is the y repeating? It doesn't matter. As long as the x doesn't repeat. That's another way of saying it. See, so this one is, yes, it's a function because each input only goes to how many outputs? Only to one. Only to one. It's like, oh, this is a bad comparison. I don't know why this just popped in my head. It's like if you're the input, you can only have one girlfriend or one boyfriend. You see, it's not right. Oh, relationships, here we go. A relation. Hey, a relationship. You don't like that one? You don't have any? You will, don't worry. Don't get down on yourself. And you're not alone. You shouldn't have a relationship right now anyways. Okay. Oh, that's a better way of looking at it. Hey, one person can only be with one other person. You can't be with, hey, I got 2 girlfriends, hey, I got 3 bros. You guys get it?
So one number can only go to another number.
Well, here each number is going to this other same number, but that's not the point. The point is -7 is only going to one. It doesn't go to another number. Okay? So this one is yes. It is a relation. This one's a relation, yes. I'm sorry, not a relation. They're all relations. Yes, it's a function. Yes, it's a function. Yes, it's a function. Let me show you one that's not. Let me show you one that's not. Ready? I'm already giving you the answer. This one's not. Ready? Plot these points. Ready? Plot -6, -3. Plot -3, -5. Plot 0, -2. Plot 4, 2. And plot 4, -5. Okay? Now this is how it would look on a graph, if I'm just looking at a bunch of dots or whatever. Now if I look at a set of coordinate pairs, well, I would just be like, okay, well, -6, -3. It would be -3, -5. It would be 0, -2. And it would be what? Oh no, there's two more. 4, 2. And 4 what? -5. Okay. Is this one a function? Where does it fail? Where do you see that it stops being a function? Yes, Dean.
At 4.
Oh, you know what? I'm sorry. You're right though, but I forgot to do the mapping. Remember, we're going to see this represented in different ways. Let's do the mapping. Go ahead and do the mapping for this. Sorry, I forgot the mapping. Let's do the mapping for this. We're doing the same thing. We're looking at the same data here, the same relation, the same information, but it's presented in three different ways in this case. How would I do the mapping for this? Well, my domain are these numbers over here. My inputs are -6, -3, 0. And do you have to write a number twice or more if it appears more than once? No, you just write it once. So 4. And what do I write for the range, which is -3? Oh, is it -5? I wrote it wrong over here. I wrote it wrong. -5, -2. Oh my God, why do I have so much? Okay, that one had more. Okay, so whether you're looking at it here on a graph, or whether you're looking at it here as a set of points, or on a table, or whether you look at it as a mapping, how will you know when it fails? That's what I need you to understand today. I think you already got it. Okay, so Dean, say that again because you hit it right on. I think you got it. What did you say that this one is not a function, right? You're right. Let's write that here. Not. Everybody know why it's not? This one is not. This relation, whether I see it like this, or whether I see it like this, or whether I see it like this, is not a function. Why? Why and where? Because according to the definition, each input has to only be paired with exactly one output. Can one X go to two Y's? No. Everybody see right here is where it fails? Right here. This one's fine. -6 only goes to 1. -3 only goes to 1. 0 goes to 1. But 4 goes to 2, and then 4 goes to -5. You see that? So this one is what? This one's not a function. Okay, I can see on a graph when it would fail. How will you know when you look at a set of points if it fails? How look at over here. How Matthew? Yes. If the x repeats, can 4 go to 2? And then I have another 4 going to another number? No. See, just the way you understand it here, that 4 can't go to this one, and then I can't have another 4 going to another one. Then this is where it fails here. You cannot have it if you're looking at a set of points or a table of solutions. You could not have the x coordinate appear more than once. You can't have it twice or 3 times. Does that make sense? How about over here? I had the y repeat a bunch of times, but was that okay? Is it okay for the y to repeat? I don't care about the y repeating. Look, see? As long as the x doesn't repeat. Does that make sense? Yeah. So I wanted you to see it on graphs. I want you to understand that and see where it fails and when it's not a function. I want you to understand it when you see a set of points, like coordinates. And if you see that it repeats twice, only the x's. Is it okay for the y's to repeat? Yeah, I don't care about the y's as long as the x's don't repeat. And let's do the mapping now. The mapping here. How will you know? By looking at all these crazy arrows. You're going to draw some arrows right now. Let's see. -6, -3. Right, you did that. -6, -3. -3, -5. Okay. And 0, -2. Oh, this one's going like straight like this. And how will you know on a mapping that it's... Because this x, each x can only go to one number. But what happens on here on this one? 4 goes to 2, and then 4 goes to -5. See, it goes. This one cannot go to two of them. It only the x can only, for each x can only be exactly going to only one y. That's how you know it's not a function. Okay? Does that make sense? Is that clear? Okay, let me show you some examples that are in the book, and let me see if you guys can, again, I mean, it's just by looking at it that you're going to know. It's just by looking at it, you're going to know if it's a function or if it's not a function. What if a relation is a function or not a function. Okay, here it goes. Ready? I'm going to put the book. Check here, check here, check here. All right, so, let me zoom in the best I could. Oh, I can go on the computer. Nah, I'm already here. Let's see, focus, focus, focus. Okay, everybody look at A. Can you guys see that pretty good? Look at A. Tell me if A is a function or it's not a function. Do any of the x's repeat? -2, I don't have another -2, I don't have another -1, I don't have another 0. So is A a function? Yes. Okay, look at B. Where does it fail? Where do you see the See? This one has a 4 already, and it has another 4 over there. That one's not a function. Okay, now let's look at a table. C. This one's not a function. Right away you can see it, or you're just saying no? Why is it not? The x's can't repeat. How about the what? Oh, -1 and positive. Oh, yeah, the zeros is where it messes up. Okay, now look at a mapping. Yes, it's a function? Does this one only go to 1? Does does the 3 only go to 1? And does the 11 only go to 1? So it is a function. Only when 1x goes to 2 y's. Very good. Okay. How about down here? Number 1. Is this, where does it mess up? The zeros? Oh no, the 5s. Not because of the zeros. Not because of the y's, because of the x's. Remember that. How about this one? None of the x's repeat. It's good, huh? How about a table? Oh, no x's repeat. What about this mapping right here, though? Where does it fail? It's kind of hard to tell which one is the one with the double, huh? I think the 1 goes to... Oh, wait a minute. The 1's going to all 3. Is that what's happening? Oh, that's a 1 half. Oh, even better. It can't go to different one. 1/2 can only go to one number. It's going to 3. Everybody see how that's not a function? Okay. How about if you see, here's another way that they say that you can see it by a graph. They say use the vertical line test. Isn't that also the same as saying if I look at a graph, it should only hit once? Every x value should only hit once? You see, this is a function because, again, they say use a vertical line test. It should only hit once. Is this a function? Well, no, it says right there. Because whatever this x value is, let's say it's 5, you'd have 5 like 2, and you'd have like 5, 4. See, it's not a function. You can use a vertical line test on graphs. Okay, last 2 right here. How about this? No. This one's not a function? Why? Oh, 2 and 5. You're right. It failed right here. It failed twice. That's not a function. This one? That one's gonna be fine, huh? Oh, there's more, sorry.
Yes.
No.
5, yeah.
Oh, yeah.
5 is?
5, yes.
How about this one?
Yes.
No.
Yes.
Anywhere you draw a vertical line or for every x value, you only have one y. That's it. You got it. You understood it. That's it. Okay.